And welcome back to the channel where we are making a video game from scratch using Love2d and Lua. So yesterday we got our death animation working, right? So we fall, we lose some health, we fall, and then we spiral out into a death, and then it becomes game over. So we need a couple of things. We need a, continue from last save or whatever, continue or quit to title screen. So the other thing I wanted to do was right there we fell into a chasm, and then we died by falling in the chasm. So like right here we fall in, we die, we come out of the chasm, and then we spin and die, and I just didn't think that made a lot of sense to like respawn after we die. So I'm wanting to do like a special death animation. So when we die by falling in a chasm, our death screen is like a looping, spiraling into a chasm death animation, and the game over is going to be on the screen there if you die in a chasm. So that's my idea that I want to try to do today, and then we'll get working on the respawn, which is probably going to be a little harder than I was thinking too, because we have to kind of carry over. We don't have any save implementation done, so we don't have where your coins reset to the last time you died or anything like that. So we might need to implement like a little saving mechanism, which we probably would want for the demo. I'm not sure. Maybe the demo is just you get one run at it. Well, I don't know. We'll have to figure it out. So with the respawn, we'd have to say, okay, well, what scene are we respawning our character at? What's our total max hearts? What is our total coins reset to? And what is our inventory like? Do we have an element that we bought from the shopkeep? So we have to kind of like have a little bit of a save mechanism implemented. So I've done something like that before with the high scores from my old arcade game. And I know it's just like you import like a little serializer, and you can save data to a file and load data from the file. So we just have to add something either in the inventory, or maybe the inn is where you go to save your progress. So you'll always wake up in the inn anytime you die, and it'll just reset your progress to the last time you saved. That's probably what we're going to end up having to implement for the demo, at least. And then we'll think a little bit deeper about what we want the game to, how we want the game to function further than that. So I do know we want a new state for, because we tried doing the chasm fall animation, and there was too many stuff. Like there was entities still being updated, there was top level tile IDs being rendered on top of us, we couldn't get the right background order layer. So I think the move is to make our own new state, and then just change state to this fall state or chasm fall state or whatever, and then have the game over and continue screen from there. So let's make a new state, and it'll be called Falling Chasm State.lua. And this is a state machine, so we need to declare that it is a class that inherits the base state. So we'll say chasm state gets class curly brace, and then we say includes, it's underscore includes gets base state, just like that. So falling chasm state, and then we have we have to declare our, you know, init. And I ordered a KVM switch to be able to swap between my Mac and my PC, because I need my PC for work, but I'm trying to get off Windows for streaming. So that comes in the mail tomorrow. So I'm hoping, you know, it'll probably take a little while to test, but I'm hoping I can never have to program on Windows for the foreseeable future. So we'll be on Mac. If it works, we'll see. Okay, so we've got this boilerplate for a state machine, a new state machine. So we do need to tell our game that it exists. In our dependencies, we'll see whatever state we have. We need to get a chasm falling chasm state. I guess that doesn't falling chasm state, but that's a little weird name now that I think about it, but it's okay. Falling chasm state, we require it, and it's in our games actually. It should be in our player. So let's move that. Yeah. I mean, should it be in our player? No, it is kind of part of our game. So it does make sense for it to be in the game. Yo, what does the asterisk mean here? In netrw? I don't even know. Okay. So let's just try to get something, you know, let's just try to get a hello falling state. Love.graphics print. And we'll say that it is a hello falling state. Okay. So we will also clear our screen. And I like to do that with a rectangle because clear just wipes the whole everything. So let's just set our color to black for now. And then draw a rectangle. Okay, X, Y, width, and a height. We'll start it at the top, and it'll be as wide as our virtual width, as high as our virtual height. And then print hello falling state with whatever font we've got. So let's try to change the state here. So instead of changing to play state, wherever we do that, let's try right here. Okay, so we need to require in our global state machine a chasm falling state. And it's a key in our global state machine, and it's going to return the state that we just declared called falling chasm state. And then we're going to just default our state machine to be that, which should be only rendering the hello chasm falling state. So chasm falling state is the name we want to change to. So let's see. Entity player chasm state. Yeah, it is not in our player state. It is in our games. Game? Entity? No. States, not entity, but game. Okay, I cannot see the screen. We need to set the color to white so we can see what we're printing. Okay, I still can't see the top of the screen. Yeah, we should be rendering. We should be rendering it okay. It's just that I can't tell if the screen is higher than normal or not. It looks higher than normal. Why is that the case? Oh, I think it's because we reset our screen position in the play state or something. We do this screen set. What do I call it? Lock screen? Lock screen. Okay, so I set a position here in the play state, so we need to set a position here in our falling state. This, I'm gonna just comment this screen lock because this is not really important to the game. This is just our development environment so that we can see what we put on screen. Geez, that didn't work either. Let's do it here in the init. There we go. Hello, falling state. There we go. There we go. You know, Scringe, I just really don't like it. The big thing is when I run the debugger in the terminal, Windows PowerShell. So okay, so there's a couple of things. My main IDE is NeoVim, right? And I try to open NeoVim. It's still opening. That took like 10 seconds to open NeoVim. So like just like that bugs me. That really bugs me. And then it's instant on my Mac. And then when I run the debugger, all the print stuff, I can't scroll through any of the debug print in the terminal on Windows. So the PowerShell just really sucks. And it's like we're using Windows Subsystem for Linux on Windows. And it's just slow and it's buggy and I hate it and Microsoft sucks. Sorry. That was uncalled for. Well, yeah. So I'm gonna be happy to switch to Mac if I can get it working with my my new switch, my switcher. Because I still need Windows. My computer is a beast of a computer, so I still need it for my video editing work. I think we want to require our player in our state machine here. Well, I guess we would have. Let's see if we have access to our global player here, because we need to be able to place him and then change his animation so that he's spinning in the middle of the screen here. So we're going to try to print a player X right here. So global player X. Let's see that. We need to concatenate these two strings. Yo, is that Salto I see lurking over there? Yo, Salto, I sent you an email today. I don't know if you saw it. Okay, we do have access to our player, so that is great. So we can render our player, and then you got a dual boot with Linux and Windows, okay, but pretty much just use Windows. Yeah, I hate Windows. I mean, I've been trying to not hate it, and I just hate it all the time. So yeah, I like Linux, but it's just too much of a headache, and the Stream Deck doesn't work with it. So I'm probably still gonna stream on Windows. I'm just gonna send the feed through my capture card because it'll be nice to offload the OBS, because I record locally on OBS and I stream, so it'd be nice to kind of offload that to my other PC while Because the other thing is we're running music, you know, on multiple different threads at all times here. So anything we can do to ease up the CPU usage during the stream, I think would help. I'm gonna try to get the Jimmy Cam set. That is a weird angle for Jimmy. Oh, I cannot figure out how to rotate the OBS cam for Jimmy here. Transform. What's the transform shortcut? Control E? Okay, why is it Control E? There we go. All right, Jimmy's back. Okay. And I think I just hold a grudge against Windows because my machine's like always like self-updating when I don't tell it to do anything. And I want my machine to just be like on when I tell it on, not like, oh, you're off and you need to finish an update. Like that really bugs me. So I don't like that. We've got access to our global player, so why don't we draw our player? And then we can change the animation of our player to the falling, and then we can add a different color, we can get some particle effects, and then add the game over the falling chasm effect. Oh, it'd be nice. Oh, it'd be really cool if we could get like 3 frames of an animation kind of projecting outwards so it looks like we're perpetually falling into a chasm. That would be really cool. Because I was thinking of just the particle effects, but without the movement, it won't feel like he's really falling. So I think that could be interesting. Okay, so we want to find the base layer of the player here. This is what we want, and we want to snag the current animation. And then we will also set the current animation, right? So we're gonna go draw our player from our, it's not self player, but it's gonna be our global player, current animation. And we're just gonna draw it at its own X and Y position, which gets instantiated whenever we make him, I guess. So let's just try to get the animation changed. So we would go to our global player.animations with an S table, and we would run, oh, it's actually just on the player, change animation, and we give it a string to chasm fall, I believe, because that should be what we declared in the entity defs. Chasm fall. Yep. Cool. Chasm fall. So we got that. We changed the animation to chasm fall. Now that let's see if it shows up. No, player's a nil value. Player dot. Line 22. Oh, self.player. Yeah, we want our global player X and global player Y here. Okay, so we've got we've got our falling character, but he is not updating his animation. So in our fall state, we're not updating our play state. How do we handle this in play state where we update our animation for the player? We update, do we just update the player? So we update the scene view. I think we would have to just update the player, because we don't want the scene view because we're not drawing maps or anything. So I think we just want to update our player. Okay, let's try it. No. Why did it not like that? We have to update the state machine, so like whatever the current state machine is. I don't remember. I don't know how we do this. We update it with delta time like this? No. Okay, so we can't just update the player. We can't just... What do we do? Walk state. Yeah, we just have to see anytime we pass in delta time to an update function. It's just here in the walk state. Okay, so we have to update. Yeah, and you know what? We are updating all of our state machines. So like when we run state machine update, we update the current state machine. So we are already doing that. Let's see. Yeah, state machine update. Oh, we're doing this in the entity. Okay, so we should only have to update our player then, because our player updates its own state machine. So if we update the player, it should work, but it is not working. And it says cannot index state machine a nil value. So oh, I think in our entity, in our entity instantiation, no, we don't even have state machines in here. Change current animation. Okay. Yeah, it should work unless we, in our entity definitions here, it's actually in our map declarations where we give it the different states. Oh my gosh, okay. Where's our player? Okay, it's not in our declaration. It's in somewhere else. Play state. Okay. Yeah. Oh. Okay, we didn't add it. I could have sworn we added it. Where did we add chasm fall? Where did we add chasm fall? Because this... Okay, I could have sworn we did this already. Let's do player chasm fall. I could have sworn we declared this somewhere, but... Oh, it's in a player state. Okay, so... Yeah, I think we might need to move this into the player state. Let's do, it is chasm falling state, right? Chasm falling state. We're going to pass it our player. It doesn't need it because it's global, but player chasm fall is what we need to change our player to now. But where did we have this, when we define our play state, I also defined right here, player chasm fall. Okay, so yeah, chasm falling state. I did that in the play state. No. Oh, this is weird. We do this twice. Because this is in the play state, and we're defining the state machines here. But then in our... Where was it? Oh, God. No, I'm imagining stuff. That's the one we just typed. Okay. Well, in our player, let's see. I got so lost. It's not in our declarations, it's in our play state. Dude, I swear we typed this out. Let's see. Chasm falling state. We don't have it anywhere else. I swear to God we typed that out. Okay, so player chasm fall is what it is now. So in our falling chasm state is what it is. Damn it. Falling chasm. We should rename it. Player falling chasm. That's too long, but I think it's going to be... You know, we have a naming convention of player and then whatever it is and then state. So player falling chasm state makes sense. So let's go to our dependencies and we'll make sure we name it here. Player falling chasm state. That's such a weird name. We need to rename the file itself. And move it, probably. So let us... Okay, so we will copy... Actually, first we'll do is we'll rename the falling chasm state and we'll call it player falling chasm state. So we renamed it and then we'll move it. Player falling chasm state, and we'll move it up a directory and into the entity directory. No, entity / player. Okay, so let's go into that folder and make sure it's there. Player falling chasm state. Yeah, we moved it. Okay, cool. So let's refresh this. It's gone, and we'll go into our player, and our player falling chasm state is in there. And this is a, god dang it, I already forgot. Player chasm fall. Player chasm fall. Okay, then we update our player. Then, player falling chasm state not found in game, because we need to change our dependencies to be the other folder, because it is now in entity player falling chasm state. Okay. Alright, state machine, nil value, like last time. Okay, so in our state, we're saying it's not the animation. The animation is chasm fall, but the state is player chasm fall. So when we update our state machine, we can say that in our, where do we even change it to this state? Change state to, we don't do it. But we have one commented out called play state. No? Change state. Yeah, not here. I'm gonna see. Change. You know what? We screwed this up because it's not a state of the character. It's a state of the game. It's like an end. Yeah, it's like a pause state because it's changing other stuff. So this isn't what we want. Let's look at our main and see where we change. See right here, change to chasm falling state. Okay. Okay. So let's do this again, and this will be called falling chasm state. In our game state logic. Yeah. I think what's throwing me off is we need a state for the game and a state for the player. So like the game is going to say, hey, let's render this chasm and have it play through the animations, particle effects, but then our player needs to load a player falling chasm state, and that just loops and just changes. And actually it doesn't need a state because it doesn't need anything fancy. We just need to change the animation to be the chasm fall animation and then update it. So we were on the right track, I think. So if chasm falling state is what we need, let's go to our dependencies. Oh my gosh, man. I might just do it manually here. Okay, states, game. We need to put it there. So we will take our player falling chasm state and we'll put it in our game. And we'll call it falling chasm state.lua. Okay. So now in our dependencies, we'll make sure that this is the game player. It's just falling chasm state. Okay. Chasm falling state. Okay, so I think we just need to fix it in our player, in our play state. Yeah. Yeah, man. We change to a chasm falling state, which is okay. So what? Falling chasm state's fine. Where did our window set go? It doesn't like the 158. Okay, so we might be... We might just have to change our player state right here. No, we have one. We have one. So why are you mad? Man, it's always the stuff I think is just not an issue, right? Like stuff I think will be so easy always turns out to be Okay, let's just not update our player real quick. Okay, that is weird. Okay, so our players, I can tell our player's animation is set to the falling animation. But we can't update our player in the chasm state because whatever reason. It says, oh, I turned it off. It says state machine's a nil value on the entity at 158. So let's just look at the entity 158. I think that's just when it's changing state. It's when it's updating state. Okay, so for whatever reason our player doesn't have the state machine at this point in time. So where do we change to the falling chasm state? Change state. Oh gosh. It should be in our main, right? Yeah, chasm falling state. Okay, so the thing is, we change to a chasm falling state before we even have a player initialized, because we're initializing the player in the play state here. So let's just not change to the falling state until after we've initialized the player, just for testing. Because we're not gonna just be in the falling chasm state, but if we have this, we can have a state timer to test, and in the update we just update it. And then after 1 second we'll say then we will change our, oh really? We will change our player. We will say global player, change state to player, no, chasm, no. What did we call it, man? Ay. Okay, well, if we go to our main, we'll see it's called chasm falling state, and it's on our global state machine. So chasm falling state, jeez. Yeah. So chasm falling state. So okay, so after 1 second, we'll change to chasm falling state, and then we need to update our player so that we spin. Dead is being true for whatever reason still. or I don't know why it was dead. Why did he die here? Player death. Okay. We'll go back to idle. Oh my gosh. Okay. So what we need to do in our chasm falling state is update our player with delta time so that we can see those new animations come out. So falling chasm state, we'll update our player, and hopefully we see him spinning. No. Do we change state? We change animation. Yeah, we change animation to chasm fall, but then we update him. It's weird that updating him is causing him to not. I think we might have to say player dead. Because we're updating him, and since he has life, I think it's changing to him to idle or whatever. Once we update, I don't know. No. There we go. Okay, well, that is chasm fall, but it's not the... We have one that's like a perpetual falling. And it's called chasm fall. What the heck? Because look, death is the one that plays frames 1 through 9, and that's where his hands are up and then he's got his head down, but chasm fall is just looping. So chasm fall, gosh. Let's not update the whole player. Let's just update the animations. Can we do that? Because we don't need to update him. We just need him to spin. Okay. Cannot update animations like that. Okay. Yeah, where do we go through our animations table and update it? Nowhere. Walk state. It's got to be walk state. Refresh. Current animation update. That's what it is. Okay. Current animation update. That's what we need to do. So we change our animation to chasm fall, and then we go into our current animation, which should be chasm fall, and we update that animation. So we shouldn't hear that death sound. We should just see us spinning and looping. Shoot, man. Chasm fall. So why does death have nothing to do with it? Let's take health off. All right. I'm confused. Yeah, it shouldn't care what our health is when we change our animation. It should just change. So we're saying we update our current animation. Man, why is this so tough? thought this would be like 2 seconds. This is after our player's instantiated. We change animation to chasm fall. That's the right one. Yep, that's the one. Is there a detection for when the chasm fall animation ends? It just loops. We gave it looping true, so it should, by the time it gets to the last frame, it goes back to the first. But I guess let's just print up what the current animation is and see if that's just totally jacked. So we'll print up the current animation right here. So we'll say player current animation. Convert it to a string. All right, well, yeah, I think something like that. See, well, is it so? If you're possible to switch it to death when HP is 0, there, yeah, that is. But the thing is, we're not updating the player, so I don't see how it would be overriding. Because our HP isn't 0 at this moment. It should be 2 right now. Now the frames that we're printing up here, we're printing up the current animation frame number at the first index, and it's 2, which should be the not even the hands up, it's like part of the spinning animation. So, oh, actually, that was on death animation, not chasm fall. It should be 2 on chasm fall, but 1 on death. Oh, geez. Okay, now I'm worried. No, we don't have a name field for the animations. See, because death should be this first frame number 1, chasm falls first frame is number 2. So that's why I'm confused. Let's see if you're right, Squinch. Let's see if we're doing something where we're saying if health is 0, but our health is not 0. If we print up our health, we would have 2. But let's see when we would change state to death. Let's see where we would do that. See if we're overriding it somewhere. Right here we're saying if our health is smaller than 0 and we're not already dead, become dead, change your state to player death. player death, not death. Death is the animation table, but player death is the state. Okay, so I guess we might need another state for our player then. Just because it thinks we're in idle. It thinks we're in idle right now because we are in idle, just idle. We're saying that our current animation gets chasm fall, except we spelled that wrong. So it thinks we're in idle. Okay, let's give us another state. Because I think that's screwing us up. So we need another player state. So we have the game state of a falling chasm state, and then we're gonna make a player state of a player falling chasm state. It's just stupid. I mean, what would be the difference? The difference would be we would be able to say change state to something and define it a certain way. But why can't we just say, since we updated our animation, oh, you know what? Do we have to assign it? No, yeah, change animation does assign it. Change animation takes in a string and it changes the state, right? Let's go see our animation class. Yeah, change animation assigns our current animation to be whatever name we pass it. Okay, so if this updates our current animation, okay, it's not, we're doing this wrong. No, this is right. That'll change our, okay. Shoot. What is wrong with me? What is this? See, we're doing this, right? We're saying if there is a current animation, let's update our current animation. And then we draw ourselves at our current animation, get current frame. I'm going to want to try to see if we can just give it a specific frame. Like, if we say that our current animation gets... We have to see what we assign into it. It's a dot animation's name. Okay. So if we say, go and give us the chasm fall animation table into the current animation. Why is it not like that? Oh. Okay, so we say go into the player's chasm fall key, pull that animation and assign it to the current animation, snag the current, we need to update it. So we can do this here, say current animation gets the chasm fall, and then we would go and update the current animation. Okay, so are we just not updating? No, we have to be updating the fall state here. Let's just say we're gonna update a test. Yeah, we're updating, no problem. Okay, so just for whatever reason, our current animation isn't updating. Let's try to do this, where we pull it, we change the animation to, I guess that's different though, that's in the player. Because we take the player. Okay, well let's do this where we can say our init is gonna take in our player. Then we're gonna change the animation to chasm fall. Okay, we'll double check that exists on our player. Chasm fall, yes. Chasm fall, yes. Okay, so when we change to this chasm fall, chasm falling state is what it is. Jeez. We need to pass it in the initialization. Okay. This has got to be where it's going wrong, because why? Yeah, we can't use the player in the init here because we don't have a player to pass in on the init. Okay, let's try this over again. Okay, so we have a global player with a current animation we're trying to draw. We need to take that player and run the change animation and give it the string of chasm fall. Then in our update, we need to go into our current animation and update it. Okay, so our frame see what's really weird is like it knows our frames at table 1 at index 1 is 2, but if we go to player death here and we change into a player death, the frame should be 1, but it's still 2. So our current animation is not updating right. And I don't know why. Because our entity def it's just death. Player death is the texture. So if we change animation to the death animation, it should be frame 1. But it's frame 2. Why? And we can't update our player because there's too much junk that isn't supposed to happen in that player. Let's try it. Let's say, you know what? Let's update our player and then update our animation anyway. Still 2. Okay, so if we say, let's go to our current animations and we will pull from our animations table the index of chasm fall, and that's what's assigned into our current animation without an S. Then we're going to update that and we're going to print the first frame, which is going to say 2. It always says 2. Okay, so if we try to index the next frame, should be 3. Nil. Why? Why is the current animation not working? Current animation is populated by running the change animation, giving it a key. So basically everywhere we have that. Then we're updating the current animation in the entity class, but we're not updating our entity in this state. So that's why we're kind of manually doing the current animation update. But it's... Oh, do we have to create animations again? No way. It bugs me that it doesn't like remember this method, but actually, yeah, we should have a create animations. Let's try it. Let's just see if it fixes it. Because we do get issues when we don't create animations in a new class. So create animations is a method that we run on an entity, right? Yeah, we run it on the entity, we give it an animations table. So we'll say that our dot animations is gonna get, and then we say we want to use the method create animations. And we give it the global table from our entity defs at, how do we do this? Player. It's not quite that, but it's close. So we say the dot animations gets the create animations entity defs player dot animations. Okay. As long as player is a class, I think that is. Then we're going to change to not death, but chasm fall. And then our current animation is going to get chasm fall. We shouldn't need that. Then we're going to update our current animation. Then we draw whatever our current animation is. No. I don't know what's wrong. Chasm fall. Yeah, chasm fall. Change chasm. You know what? It might be because when we, you know what? It's because, it's because we init this. When we init this, our global player doesn't exist. So it doesn't know how to do this. So let's just do it. This is bad, but let me just see if it changes anything. At least, okay, we got the correct index and we got the correct the frame, right? So it's because our global player in the init doesn't exist yet. So we need to not do that. Just need to update our animation. Why does it hate us? Why does it hate us so? Okay. Yo, hey, thanks for hanging, Squinch. Yeah, thanks, man. Yeah, drive safe. Yeah, have a good day, man. Such an annoying problem. Like, I'm just trying to get the animation spinning, you know? Okay. So I think the issue is this class doesn't have an idea of what the... I mean, let's test this assumption. Let's say, okay, when we change to falling state chasm, we will update our current animation. So if we give it the current animation at frames 2, you know, it's... why would it even be a nil? But let's just try to change the animation. Change animation to chasm fall. And then we update the current animation. Okay. That's all I wanted. So, all right. So, yeah. It was just a confusion of since this is technically a game state, the game state init didn't have access to the global player because it wasn't created yet. So once we change to the game state, then we're updating. And actually, we would probably want to do this. We would just say update your current animation, but then when we go to change, like in our play state, when we go to change our state timer here, not here, in our play state. Yeah, what we're gonna do is we're gonna change our animation to chasm fall, then go and update, so that we don't reassign our animations table every single frame. So, son of a... This is so annoying. Why would this not work? We're doing the same thing. But we don't need to update. We don't need to update our chasm fall. We don't need to change our animation to chasm fall every single frame. It's just silly. So I guess, I mean, do we really... we say that our current animation gets to be equal to our entity defs at index player dot animations. Chasm fall. What the heck? Today is not my day. Okay. I mean, let's just take a quick look at how we do it for any other state. Because we shouldn't have to pass in the update there. Let's just do this where we say like init gets false, and we'll say if we're not init yet, then we're gonna go ahead and run the change animation and give it chasm fall. All right, and then init gets true. All right, we should spin around. All right, should not take that long. Okay, so let's get rid of this. Okay, we draw our player. We need to draw him in the center, not at the player X, but the middle of the screen. So we'll go virtual width Virtual width divided by 2, shifted by 8, half our tile size. Same with this virtual height divided by 2 minus 8. So we should be in the center. Cool. So if we fall into chasm, we're going to trigger this. Let's just try to get some particles on screen so we have particle system. We'll have to make new animation for this. System. Okay, so we have to do something like this. Okay, so maybe what we can do, yeah. We have a particle system, so let's give our chasm state a particle system. And we're going to create it using a global particle. And actually, the better test to snag for this is the corrupted particles, which is on our entity class. Yeah. Okay, so that's what we want. Okay, so for our particle system, we have 800. We're going to move them. I don't know, we'll just give some place. Set this emission area. We'll need this to be a lot bigger, but then we update, then we need to render the particle system after our player. We have to draw the particle system, not render. So instead of render, we draw it. Okay, we got a nasty little particle system. Virtual width divided by 2. We'll just have to tweak it now. So we have -2. Yeah, let's just put it at the direct center. Virtual height divided by 2. Let's give our particle system a more purpley color. We want like a bigger border ellipse emission area. So we'll try maybe 10. And then particle lifetime, maybe 6 seconds. And then maybe this is bigger at 32. And then the colors, red, green, and blue, we want it to be purpley, so heavy on the blue and green, is that right? But then it fades to more blue. Let's see. Okay. Yeah, I mean a chasm like that, right? So we just need to place this inside our player, or like around our player. So for whatever reason, when we do this move to, I think this move to might be screwing it up. Yeah. See, like, it would be cool if we could scale up. Like, if we had, like, 3 particle systems kind of, like, scaling up, so it's like a tunnel that he's continuously falling down as it kind of grows. So, like, I think I want to kind of... I want to speed up the tangential acceleration. And I want to enlarge the emission area. And then... let's see. Yeah. Oh, that looks nuts, man. We need more particles. I'll tell you that much. 800 is too much? Maybe not. Maybe not. Emission rate, let's bump it up. Let's go 300. 3-second life, 800 emission. I don't know. I can't tell if we need less tangential acceleration. They just fade too fast, I think. Like, yeah, I think we need longer. Exist longer. What the heck happens if we give it a huge tangential acceleration on the X here? There we go. Yo, that looks nuts. Yeah, that looks pretty freaky. Now, it would be really cool if we could get like an illusion going where it's like this ring is getting bigger and it leaves screen and then another one comes up and it's like he's falling continuously down this thing. So let's take the border ellipse and we're gonna keyframe this, you know, from 20 to however big it needs to be to get off screen. So if 20 is like, I mean, we would enlarge it so it's kind of like an illusion. So let's see what 100 looks like and see if it's off screen. It looks, yeah, just off screen at like 100. Oh, that's nuts. So let's do, okay, so what we'll do is we'll snag a emission area width, or emission area will be 0. Over time, we need to update the emission area to be incrementing by delta time. We'll just scale it by 2 just to see. And then we draw it with a dot emission area and a dot emission area. So this should be growing in size. So it should start at 0 and then grow and give us that illusion of him falling down a chasm, right? Holy crap. It needs to go faster, so we need to scale it more than 2. Whoa, that's nuts. Yeah, it needs to go a lot faster than that. But also, we need to render the player on top of the particle system. So we'll just render the particle system before. Okay, let's speed this up by like 8. Okay, should be fast. Should be fast now. Wow. Whoa, that's nuts. See, like if we had another one grow underneath him as the second one's coming out, and it can kind of look like he's falling down this tunnel continuously. Sweet. Oh, that looks so cool. So if we kind of mimic it, we can walk in here. Da 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 da. 1 second was not enough time. Oh no. Oh no. Another reason to hate Windows, man. Why? Why? I hate when this happens. Okay. Normally when this happens, I have to reset Tmux completely. Okay. All right. So let's I don't know, something about it is like might be too much on the X tangential. The speed might be a little bit faster. Like if we speed it up just a bit. Oh, that looks so cool. That looks so sick. Okay, so what we want to do, we want to set a table of particle systems. So we'll say P system with an S gets an empty table. And then we're going to put a particle system inside our P systems index 1. So this particle system is in this one. Now instead of this P system update, we're going to go P systems with an S index 1. What is going on? Okay, so we're going to update the first particle system, and then we're going to render not the particle system, but the systems index 1. Ay, ay, ay. Here we go. Tem systems index 1. Okay, so we should have nothing changed other than the fact that now we have a table of particle systems that we can do, because we want multiple, we want another one coming in underneath us, and basically just an optical illusion. As soon as the first one's big enough to go off screen, we're going to reset its emission area back to 0, start scaling it back up. Now I do think it should be a little faster. Let's just go crazy and see what 32 looks like. Twice as fast. Should look like he's falling down a chasm. Oh, that's crazy. Let's just go crazy and see what an 800 emission looks like, because our whole particle system's 800, just to see what it looks like. Whoa, that's nuts. It's got like this weird waviness to it that I don't think I like that much. I mean, it's because we're scaling the... I think we need to just boost its acceleration if it's growing faster. I think we just need to boost its acceleration here so that it doesn't look like it's collapsing in on itself. So we fall. Okay, that's looking cool. Let's go back to like 600 emission rate. There we go. Okay, I'm curious what something like this might look like if we had another one come up right underneath it. That looks so crazy. Okay, so basically what we want to do, we just need to get one of these looping and then we can offset them. So basically we're going to set, we're going to grow the emission area, and we tested it about at, was it 100 or was it 200? Let's test it real quick again. I think it was the emission area, and if we change this to, we want a size that is like just off screen. So so we know when to reset it. And I think it was like 100 or 120 looks off, fully off. So I think it was 100. And 100 is like just on screen still. Okay, so that's probably fine. So let's get our emission area back here. Oh my goodness. Okay, so we're gonna increase our emission area by this speed. Then we're gonna render it. Then we're gonna say if our emission area is greater than 100, we're just gonna reset it back to 0 so it can do its thing again. Nice. So now that this is looping, we can just add one more particle system and offset it so that it's coming in as this other one's going away. Or, you know, coming in about halfway through. So it's like a continuous illusion. I still think we need more particles. Let's try, like, I want to go like absolutely nuts. 8,000. Let's just see if it can even do it. I don't even know. 8,000 particles. Wow. Nuts, man. That looks killer. All right, what if we... Yeah, I want to boost this more. Like, let's just go like 150, 100. Let's see. Jeez, man. Yeah, I think it's this second acceleration that gets them sent too far. Let me see, because the faster we spin the second one, no. Because they get like a whoosh, and like a lot of the smaller, some of them go really far. What happens 0 on the second tangential? Wow. Holy crap, man. I almost feel like we can pair two of them together. Dude, that's nuts. Should make it a little brighter, too. It's really dark. I mean, it's supposed to be. You're falling down a freaking chasm. Wow, this is cool. Okay. I don't think the 0 is the right move, but I do think that the lesser it is, the more impactful it kind of looked. I just want to see what 300 looks like. Okay, so that's the one that kind of whooshes it out. Now, it is good to have some of those, but not a whole lot. Wow, that looks so crazy. I mean, 8,000 is too much, right? We'd have to test on the mobile deployment and see. Holy crap. That looks killer. Okay, I want a deeper purple here at the beginning. We might have to go to a color picker website and figure out these values. Okay, let's go Let's go down to 400 and see, or 4,000. See, that's almost like not even noticeably different. Yeah, that might be the sweet spot. 1,000 might be the sweet spot. Cool. This is sick, man. Okay, so let's get a second particle system. So we'll reset this to 1,000. Let's make sure that doesn't change anything. Yeah, it does change some stuff. Okay. Because the emission area over the lifetime is 6 seconds. So if there's 1,000 per second, we kind of get capped. Yeah, let's try this. That looks like a decent starting point. So I feel like we need to speed it up just a tad. Okay. Wow, that looks so cool. Okay, so let's do our second particle system. And it'll be just offset of our other one. It'll be the same deal. Emission area needs to be offset. So let's say that this emission area gets a -50. Emission area 2 gets -50. And then we're going to increment emission area 2 by the same speed. I don't know what happens if you give it a negative emission area. But we need to update our second particle system here. And then if our second emission area is greater than 100, we reset that one to be 0. And then we need to render the second one as well. Okay. Yeah, I don't really see the offset. I think, I don't know how to do this. Because the loop is kind of set on the emission area getting to be bigger than 100, which is variable depending on what speed we put in. So if we give it the same thing, it'll just be the same. So like we could try giving it a different speed on the emission area, but it won't be the same kind of offset. But let's just see. No, it doesn't look like both are rendering. We can try render particle systems 2. Particle systems 2 piece. Okay. Yeah, let's just see if we're rendering the second one. Okay, we are. Yeah, it's just the offset wasn't very good. You know, we need like a little timer. I don't know. We need like a... We only want to start scaling this if our P-system offset is greater than, let's just say after 1 second, let's go ahead and start updating the emission area. variables make our P system offset increment here. Okay, and then let's render both. And we could change the color just to make sure we're rendering them both differently. So like, let's just make one super green. We'll make particle system 2 super green to spawn it with, and we'll see if we're rendering both. Yeah. There's no offset, you know, like does this just need to be like 3 seconds or something? Yeah, they're kind of just spawning all at the same time, same logic and everything. Emission area 2. Emission area. Oh, we're doing this. Oh, okay. Okay. That makes sense. Okay. All right. We didn't see it. Okay, P system offset, we update it over time if it's greater than 3 seconds. Greater than 1 second, we're going to start scaling our emission area 2. We're rendering our second particle system with an emission area of emission area 2. So we should get some green, some purple, then some green. Nice. Cool. So we need to get this offset working, right? Like good proper timing. Right now the green happens too soon after. So maybe it's 3 seconds like we tried. Let's try 3 seconds. That was too much. Maybe 1.5. Still too slow. Gosh, that looks crazy. It's tough because it's like we need... Maybe what we can do is we could start scaling it once the emission area to the first one is greater than 50. But then we won't increment it. We'll just have a trigger for it. So instead of this offset pieces, we'll have a trigger. And we'll say we're false, but if the emission area of the first one, once that becomes greater than 50, which is half the size of the screen, so should be theoretically like, you know, right in the middle for the timing. If it's greater than 50, then we're just going to trigger. We're going to trigger this to update. And then we're going to do the same thing. We're going to say, okay, well, now that we've triggered, we say if we've triggered, then we're going to start scaling this. And then we render the second one at the emission area, which is 0 anyway, until the trigger. So this should be kind of alternating. Come on. Offset. Where did we use offset? not quite. Okay, so let's see. It's less than we thought. Because it's like the speed at which it grows, since it's a circle, that's a little too fast. Well, oh, now that's way too slow. Why are they different rates? Oh, we changed the freaking rates. Okay, that was too fast. It should be consistent though. Bing, 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 bing. So we need to just offset it a little bit more time. Let's try the 50 with the proper... That's close. That's pretty damn close. Okay. Let's change this green back to a purplish color and see if it looks like he's falling. We can afford a little bit of a different color. Just to kind of give it some texture. It doesn't look like he's falling. Yeah, it doesn't look like he's falling. I don't know if it's because of the tangential acceleration here. I want it to look like he's falling. Wow, that looks wild. That's just way too fast. Oh, it's not the emission area speed, yeah. Okay, so let's just maybe see what 50 looks like. Yeah, it doesn't look like he is falling, man. Let's try this one again at 30. We might have to slow down that second argument and see. Yeah, I think what it's missing, we need to swap the opacity, because when it's further down the chasm, it should be harder to see, and it should be brighter when it's outwards closer to us. And the fact that some of them aren't expanding at the same rate is why it doesn't look like he's quite falling. But that's a good... I bet if we switch these, if we switch the alpha channel on the life cycle of the particle, it would look a lot better. Oh, and then we can maybe slow down the y-ward tangential acceleration and see if that helps. Whoa, yeah, buddy. Holy cow. That's looking sick. Yo. Whoa. I kind of love that. That looks nuts. So let's try to trigger this once we fall down a chasm and lose all our health, right? So we by the time we change to first of all, let's unchange. Is it in our play state where we go straight to the chasm falling state? We have a timer. We have a play state timer in our play state. Where is it? Yeah, we have this state timer. Let's just not change our state for right now. And we want to instead change our state here only if our player dies and is colliding with a chasm. So if we search for dead here. Okay, so we're gonna swap to death. We're gonna change our state to player death. We're gonna play the death sound, but then we want to check, you know, if we collide with a chasm at this very moment, then we're going to change to our other game state, which is this chasm fall. So let's we have to see if we're colliding with any chasms, which we're doing in our map, I believe. We have these methods defined in our player. This should not be in the player though, right? I guess so. Okay, so we can cycle through. We have the methods, so we can just see if we're colliding with any chasm. So we would have to cycle through. We would say for key value in pairs of, it would be our scene view dot current map, and it would be the chasms table of our current map. We're going to cycle through, and we're just going to see if we, you know, if our player, so ourself, collides, which top left collide chasm. Let's just try one for now. If we top left collide chasm, does that take any arguments? Takes in a chasm, so we have to feed it the value that we're looping through. If we are colliding with any of those, we're going to change the state to be this chasm falling state. So as long as by the time we're dead, we're at least top left colliding with any of our current map's chasms, we should change to the chasm falling state. So let's see if we can trigger it. So we're one away from death, and then we die. Son of a bitch. Player 168 didn't like this. For key value in pairs, it's not scene view, it is... No, yeah, it should be scene view. Okay, so let's do the chasm collide. It's the map self.row. So the scene view dot current map dot row. Jeez, okay. So that's a little messy. But here, we'll do this. We'll say, and you know what? We should only need to check one of the chasm collides, because the tween values, once we get pulled into a chasm, our X and Y gets tweened to be inside it. So we don't need to check all the conditions. We should just have to say, if we top left collide with one, then it is a collision, and we'll fix this to be our global map. Our scene view dot current map dot row is the first, and then scene view current map column is our second dot chasms. That's the chasms we're cycling through, and we're checking for collision to change into the chasm falling state. So once we lose our heart, we've got one heart left. Then let's have the bat shoot us into the chasm and trigger the chasm state. Let's see if it works. Oh! That was cool. It just messed up. I couldn't tell because we were just out of range when he hit us, that when we died, we weren't technically colliding. So let's get closer to the chasm here. And you know what? Right when he shoots us, we're dead. So that's why I spun before. So we have to fix that state. We have to fix that state so that we don't trigger... I mean, we technically died before we fell in the chasm. So now, let's see. We're going to walk into the chasm, fall. Wow. Look at that. Oh, that's epic. I guess that's really cool. It doesn't quite look like I was hoping with, like... It doesn't look like tunnels. Like, I want, like, parallax tunnels kind of coming at you faster. You know, like I wanted, I don't know, but it looks cool. Like I think that gets the point across. Like it's supposed to be this kind of gnarly alternate death, game over screen. Yeah, thanks, Rough Cookie. Yeah, I think it's cool. I'm a little worried that the particle systems would be too much on the web deployment, but this looks super sick. Like at least, wow. Yeah, his mouth still bugs me a little bit. Like his mouth looks like a Tetris piece spinning, which I don't quite like. And it's just, oh, you know what we can do? We can just kind of oscillate him in the circle like he's spinning, instead of just spinning on an axis where his mouth is the constant pixel there in the middle. We can just give him a little oscillating sine wave or a circular path there. And I think that would really help how this looks. But yeah, like we would trigger, I think I'd want to trigger something similar to the curtain call. Like we would just fade to black. We can fade to black if you fall into a chasm and you're dead, and then trigger the state instead of right away. Oh, see, that time it didn't work. Maybe, yeah, we must have not been top left colliding or something with it. Let's see. That's weird that it's not working now. Yeah, we changed nothing, right? We changed nothing. What the heck? We changed nothing. Okay, well, let's go to the chasm that worked, right? Was it up here? Well, we would chasm if our health is minus or equal to 0, we're dead. We change our state to player death. I guess we would do this. We would see if we need a change to a falling before we die. I don't think that would really matter though. Okay, I don't know why it's not triggering. The spit on the head still gets me. That's really funny. Okay, we changed nothing and it's broken now. Okay, if our player collides with the chasm, so what are we doing? Yeah, if our health is dead and we're not dead, okay. Yeah, this should... I don't get why it stopped triggering. Okay, that one worked. Why is it not consistent though? What the heck? I don't know. I don't know. I'm running out of steam. We'll add a to-do here, and we'll try to figure out why this is not consistent. But for now, let us take a look at our get diff here. And oh, and you know what? I just figured out a new way to use get fugitive. If you just do get fugitive, you can see files one at a time here, like there. This is the whole class we added today, and then we can add it to the staging area, and then we can see our other changes. There's a way to... That's not what I want. Yeah. Well, I guess if we add... That all looks right. Let's just add them, and then I want to run get diff and just make sure. Oh, come on. Alright, I'll have to figure out how to use that better. Alright. Commit. We'll say we added a falling into chasm state, which looks really cool when it works. We have to figure out how to get it consistently working when we fall. But other than that, I think that'll be it for the night. Let's see if Hypnotic is programming. And Hypnotic is playing chess. We don't got any homies streaming. Well, we don't got any homies. Okay, well, I'll just read out to someone I'm following here. Yeah, it's the rough cookie. The colliders for the chasms are like really tiny in the center of us. So since when we collide with a chasm, we drag our player into the chasm. Technically, any of the little boxes should be colliding because we pull ourselves, we tween our value into the chasm. So the bug probably is in there somewhere. But technically, it should always be a top left collide with a chasm because the box is inside our player and we tween our player's position. So the bug probably is in there. But yeah, that a good catch. I think that's exactly what it is. So I think we're just not tweening the value fast enough by the time we trigger the falling animation, and we trigger the death based on the falling animation's last frame. So there could be some lenience in there where we're not triggering the death late enough. We're triggering it too soon before we've tweened deep enough into the chasm for it to register a collide on top left every time. So I guess if we enter from the bottom right into the chasm, it should always trigger because we would be closest to a top left collide with a chasm. So that's probably the bug. But good catch. We'll raid out Amaris Sky's playing Bloodborne, which is a great game. So we'll just raid out to her and call it a night. Thanks for watching, guys. I'll be back tomorrow and we'll get some more stuff working.